Hola! Do you know what is a parabola? Parabola is an open curve that looks something like this. You might have heard of parabolas in physics. So when you do projectile motion, where we throw a ball like this, we say it follows a parabolic curve. Or in mathematics, what does the graph of a quadratic equation look like? That's right, it has the shape of a parabola. In mathematics also we consider the parabola when you take a cone like this and if you cut a plane like this. So if you cut a cone with a plane, the curve that is formed, here you can see it's called a parabola. In this video, we are going to learn all about parabolas and I'm going to make the concepts absolutely easy and crystal clear for you. We are going to look at the equation of the parabola and we are going to solve different questions on this topic. So keep your pen and paper ready and make sure you guys watch the video till the end. But before we begin, I just want to say, do check out the courses on our website manochaacademy.com and our Android app. To make it easy, I'll put the links below. So are you ready to go into open curves, which is parabolas? If you take a cone like this and cut it at different angles, you will get these different shapes. So if you cut it like this, we get a circle. If you cut it at an angle like this, you'll get an ellipse. If you cut the cone like this, you'll get a parabola. And if you cut it like this, you'll get a hyperbola. In fact, you'll get two hyperbolas, one at the bottom nap and one at the top nap. And here you can see in this picture, I've shown all the shapes for you. So can you guys see that circle and ellipse are closed curves, right? These are closed, whereas parabola and hyperbola are open curves. And again, remember, these are called conics or conic sections because they can be obtained by cutting a cone. We get all these different shapes because it matters at what angle you're cutting the cone. So we measure the angle between this plane and this vertical line of the cone here. So if I take this plane and the vertical line, and if the angle, this angle is called beta, is 90 degrees, then you can see we will get a circle here. We get the shape of a circle. Now our topic today is parabola, so let's take a look at it. How do we get a parabola? For parabola, again remember this is our double-sided cone, and this angle, that this line when you rotate it, which forms the cone, it makes with the vertical. This angle is typically called alpha in the textbooks. Okay, and this plane, the angle that the plane, the cutting plane makes with the vertical, so this angle is called beta. Now in parabola, the special thing is that angle alpha is equal to your angle beta. So this plane is basically parallel to this line. Can you see here? So if you visualize it, this plane that you're cutting with is parallel to this line, and the shape, this open curve that we obtain, this is called a parabola. And that's going to be the topic of today's video. We are going to look more at parabolas, what is its equation, what are the different types of parabolas. So let's look at that. We saw how we can obtain a parabola by cutting a cone at a specific angle. And as we discussed that angle alpha and beta should be equal, then the curve you'll obtain is a parabola. But there's another way of defining a parabola which makes the visualization much easier. Let's take a look at that. So a parabola can be defined as the path traced by a moving point so that its distance from a fixed point focus and from a fixed line is always the same. So let's visualize this with a simple example. Let's first take our fixed point, which we are going to call as the focus. So let's say this is our fixed point focus, and I have taken a straight line over here, which is called as a directrix. So L, we have our line L here, and this is typically called the directrix. Now imagine we have a firefly. That's my favorite insect, right? The glowing one. So imagine you have a firefly and it is moving, okay? And this firefly moves in such a way that the distance from this fixed point and the line is always the same. So let's visualize it. How will it move? So let's say our firefly is somewhere here, so that its distance from the focus and this straight line is the same. So let's say it's somewhere here, okay? That means this distance from this fixed point focus. And how do you measure the distance from a line? you'll drop a perpendicular. Okay, because remember it's always the shortest distance, which is the perpendicular distance. You'll not measure the distance at an angle. We will drop a perpendicular like this. So when these two distances are equal, that means it's following our parabola. Okay, so let's say this is 10 centimeters, this is 10 centimeters. Now our firefly moves forward, okay, in such a way it has to maintain this distance, right? Distance from the straight line and the focus. So let's say it is somewhere here. So this distance from the focus and again the perpendicular distance from the straight line are same. Let's say it's 7 centimeters now. Now again it moves ahead. It comes somewhere here, let's say. So once again the distance from focus and the line is same. And now let's say it moves and comes somewhere here. Okay, I'm just drawing it roughly. And this distance and this distance, well, in fact it should be somewhere here. So let's maybe draw this one here, and this should be exactly the middle point, right? So it should be somewhere here where this distance and this distance are equal. So if we join the curve for the firefly, all these points, you'll see it's following a kind of a curved path like this, and this is basically our parabola. And it can go down as well, right? As long as it's maintaining the distance from this fixed point and the perpendicular distance from the line are equal. So this is how you visualize a parabola. Remember that fixed point, what is it called? F for fixed point, F for focus. And the line L is called a directrix. And of course, the fixed point and line, they both lie in the same plane. So here we are talking about two-dimensional. This is a two-dimensional plane, right? A flat plane means flat surface. So our fixed line L, the directrix, and the fixed point, which is our focus, they both lie in the same plane, same flat surface. So this is how you can visualize the parabola with our firefly example. Now let's look at the important parts of the parabola. So we are going to look at the different parts of the parabola. Remember, we have talked about the focus already. Focus is that fixed point from where the distance to the focus and to our line needs to be equal. So let's say this is your parabola. This is the parabola. This is where the focus lies. So this is where the focus lies. So you can see that the focus will lie in the curved part of it, right? So it curves this way, so focus will be somewhere here. Okay, that is our fixed point. So focus is that fixed point we talked about. Next is the fixed line. Remember, we talked about the fixed line L, which is called the directrix. So this line is here. This is our directrix. And remember, the firefly has to maintain the same distance from the focus and the perpendicular distance to the line. Clear? So these are focus and directrix. And then the line which passes through the focus and perpendicular to the directrix, that is called the axis of the parabola. So if you draw a line passing through the focus and perpendicular, you can see 90 degree to the directrix. So this line you guys see is called your axis. So draw this diagram and remember these names and parts. Then the point of intersection of the parabola with the axis is called the vertex. Very important point here. This is the vertex of the parabola. So point of intersection of this axis and the parabola. So where will it lie? This is my vertex, and let's label it with V here. And the last one, the line segment passing through the focus and perpendicular to the axis. So let's draw it. This line segment which passes through the focus and which is perpendicular to the axis. So like this. See, 90 degree to the axis. This line segment AB, that is called the latus rectum. So note the last one down. This AB marked in the diagram is your latus rectum. So clearly look at all the important parts of the parabola, right? Focus, vertex, axis, directrix, and this AB, let's label it, AB is called your latus rectum. So these names and words are very important because they are useful when you're solving the questions. Now there's a very important relation between this vertex, focus, and this directrix. Can you tell me where does the vertex lie? So remember the definition of the parabola. This point should be equal distance from the focus and the directrix. That means this distance to this line should be the same as the distance to the focus, right? So can I say that V is exactly the midpoint of, let's say if I label this as L, it's exactly in the center of L and F, correct? So V is exactly in the center. That means this distance VF is the same as VL here. So remember, vertex lies in the midpoint of this part, right? The focus and this directrix. Parabolas can be of different types depending on where your focus and directrix lies. And to make things simple, we are going to consider parabolas where the vertex is at the origin. Okay, so guys, remember what was the vertex? This point was the vertex, you guys remember, right? Where the parabola meets the axis. And this point we are going to take as the origin in the coordinate plane. So if you guys look at the pictures I've drawn here, this is our vertex, and you can see it is the origin 0, 0. Same for this parabola as well, and same for all of these guys. Now what is the difference in these parabolas? Why are they curved differently? Because the focus and the directrix are different, or you can say the axis of the parabola is different here, right? So for example, in this parabola, the focus lies here. Remember, the focus always lies within that curve. So this is my focus and this is my directrix. So when you draw the parabola, it will turn out to be like this. So directrix is lying on the negative x-axis. It is perpendicular, it is parallel to the y-axis, but on the negative x-axis. If you look at this parabola, you can see that the focus will be here, and this time the directrix is on the right side, okay, cutting the positive x-axis. If you look at these parabolas, the focus will be here, and directrix is always opposite to the focus, right? So see, it curves this way, so focus will lie within the curve. Remember that. Focus lies within the curve, and this is my directrix, okay? And for this parabola, where will the focus be? That's right, it's going to be here, and the line will be on the opposite side, parallel to the x-axis and cutting the positive y-axis. Again, see, the vertex is always the origin, but the axes are different. Here the axis of the parabola is the x-axis. Here as well, the x-axis. For these parabolas, where the axis is the y-axis, right? The line passing through the focus and this vertex. You can see this is the axis. Now these parabolas have different names because you can see in the coordinate plane their shapes are looking different. So this type of parabola, which has the curve on the right hand side, is called the right-handed parabola because the curve is on the right side of the y-axis. And here you guys can guess what will this be called? That's right, this is on the left side. So this is called the left-handed parabola. Now what about these guys? This parabola, which looks like the smiling parabola, the smile over there, it is the upward parabola because its curve is upwards. So this is called, note it down, the upward parabola. And this parabola, which looks like that sad frown, right? So that was the smiley one. This is the sad parabola. It is looking down. It's looking downwards. So this is called the downwards parabola. So depending on where it opens up, right? This opens up to the right side, right-handed. This opens up to the left, left-handed. This opens up upwards, upward parabola. This opens up downwards. So remember, you can have 4 types of parabolas. And again, I'm repeating for simplicity, we have taken the vertex to be, and we will keep the vertex to be at 0, 0. And these are the 4 types of parabolas. Now let's look at the standard equations for parabolas. Remember, we said that the vertex of the parabola we'll take it to be the origin, 0, 0. So here you can see the vertex of the parabola is at 0, 0, and in this as well. So this is a nice simplification we make so that our standard equations of parabolas are easier. And as you guys can see, what is the axis of the parabola? Remember, axis of the parabola is the line passing through the focus and perpendicular to the directrix. So here you can see what is the axis of the parabola? That's right, it's going to be the x-axis. So these are the coordinate axes. This is the x-axis, this is the y-axis, and you can see this is the axis of the parabola. And it is also called the axis of symmetry because you can see it cuts the parabola into exactly two identical parts, right? These two parts are symmetrical. So we can say this is our axis of symmetry. So this was the case for the right-handed parabola. Now when you look at the upwards parabola, can you guys tell me where is the axis? Remember, once again, axis passes through the focus and perpendicular to the directrix, and it also passes through the vertex. So you can see that the axis of the parabola is the y-axis here. And once again, it is the axis of symmetry. It is dividing the parabola into exactly two equal parts. So this is our axis here, the y-axis. So in all our parabolas, we looked at different types. Let me show you. You can see the axis will be either the x-axis here, axis of symmetry, or it's going to be the y-axis, whichever type of parabola we see. And remember, the vertex is always going to be 0, 0. So now let's look at the standard equations of these parabolas. So let's see if we can write the standard equation of the parabola, and we'll start with the simple right-handed parabola. You can see it is opening to the right-hand side. So we are going to write the standard equation for this parabola. Now what do we mean by standard equation? What is our goal here? We want to write the equation that will satisfy all the points on the parabola, right? So any point that you consider on the parabola, like this one, x comma y, or any other point here, x comma y, what is the equation that connects this x and y? That will be the standard equation or the equation of the parabola. Now to get to the standard equation, we'll again assume that our vertex, remember, is the origin. So the parabola is placed in such a way that the vertex coincides with the origin of the xy plane. Now our focus, since this is a right-handed parabola, the focus will lie here in this open curved part, and we will put this focus at this point a comma 0. You can see it's on the x-axis, so its x-coordinate is a and y-coordinate is 0. The directrix will have to lie on the other side, and since the vertex is always in the middle, right, because this distance from the fixed point focus should equal to the perpendicular distance, which means our directrix will be at x equal to minus a. Do you guys agree? That means this point will be minus a comma 0. This is a comma 0. All of you can see that. So clearly this distance is a and this distance is a. Vertex is exactly in the center. But our goal here is to find the general equation, this equation, or what we call the standard equation for any point x comma y. Now how can we do that? We will go by the definition of the parabola. Remember the firefly example? So the firefly has to move in such a way so that the distance from any point on the parabola to this fixed point focus, f, this distance is equal to the perpendicular distance to the directrix. Now I've roughly shown it here. It may not be looking exactly equal, but you guys get the point that this distance pf is equal to pm, correct? And now we need to find, based on this definition, what is the connection between x and y. So how do we do that, guys? So what is this distance pf? Can you tell me? This is a 2D plane, coordinate geometry. So basically we need to find this distance pf. We will use distance formula. So let's do that. So to find pf, we'll use the distance formula, and you know pf is going to be equal to square root of x minus a whole square plus y minus 0 whole square, right? X minus a whole square plus y minus 0 whole square. But you know, we don't like all these square roots, so we can do something smarter. Why don't we square both the sides of the equation? So rather than starting with pf, I'm going to start with pf square equal to pm square. Okay, so the left hand side pf square is basically going to be x minus a whole square plus y minus 0 whole square. And now guys, can you tell me what is pm, or what will pm square be? So pm is this perpendicular distance, right, from this point xy to this line. What will it be? Do you need to use the distance formula here? No. You can directly look at the diagram. You can see this distance is x, right, from the y-axis to p. This part is x and this part is a, because the directrix is at x equal to minus a. So do you guys agree with me that pm is going to be x plus a? That's it. So I can put here x plus a whole square. So write this down and just simplify. So we'll just, expand it out, and what do we get? X minus a whole square. So this is going to give me x square plus a square minus 2ax plus y square. And on this side, I'm going to get x square plus a square plus 2ax. Okay, there you go. X square is going to get cancelled. Your a square is going to get cancelled. So finally, what are we getting, guys? We are getting, for this right-handed parabola, y square equal to, if I take the 2x over there, 4ax. Y square equal to 4ax. And note one important point, a is greater than 0. Okay, this value a, we always take it to be greater than 0, and we have written the focus as a comma 0. That's our focus point. So for this case, and a is greater than 0. So this is our standard equation of this right-handed parabola, y square equal to 4ax. And the proof is very simple. By the definition of the parabola, draw this diagram using coordinate geometry. You can easily get this standard equation or the standard form of this parabola. But remember, not for all parabolas. This is for the right-handed parabola, which opens on the right-hand side. And what is the importance of this equation? The importance is that if you take any point on this parabola, x comma y, it has to satisfy this equation. Y square equal to 4ax, where a is some constant value greater than 0. Okay, so any point that I take on this parabola, x comma y, will satisfy this equation, y square equal to 4ax. Now you might say that I don't believe this is the equation of the parabola. Okay, let's say you don't believe it. So this is the equation, y square equal to 4ax. Now you check if it is satisfying the definition of the parabola. How will you do that? You can start off by looking at the distance, right? PF. What is the distance PF here that you look at? The distance from this, any point on the parabola, x comma y, to this focus here, which is a comma 0. So you are interested in calculating this distance. How do we do that? Using distance formula. PF will be what? Square root of x minus a whole square, because these points are x comma y and a comma 0. So x minus a whole square plus y minus 0 whole square, which is y square. Clear? Now I tell you that the equation of the parabola is y square equal to 4ax. That means all the points on this parabola must satisfy this equation. Agree? So can we substitute y square as 4ax here? See, because these points are lying on the parabola, so I can say, hey, instead of y square, I'm going to put in 4ax. So what does this PF distance become? Square root of x minus a whole square, and I'll replace the y square with 4ax. Now guys, let's go ahead and simplify this, whatever is under the square root. So what will this be? X square plus a square minus 2ax plus 4ax. So basically what will you get? Square root of x square plus a square, and this will give you a 2ax. Minus 2ax plus 4ax is plus 2ax. Isn't this inside the square root x plus a whole square? Yes. And if you take a square root of that, you're going to be left with x plus a. And guess what? What is x plus a? X plus a is exactly the distance from the directrix. So can I not say that's equal to PM? So if for every point PF is equal to PM, that's the definition of the parabola, that parabola is that curve where the distance from a fixed point is equal to the distance from a fixed line, the perpendicular distance. So there you go, we have proved it. Since PF is equal to PM, that means our equation of the parabola is correct. So equation of the parabola, which is y square equal to 4ax, is absolutely correct, but once again for a right-handed parabola. We have taken that as an example. You can prove this same thing for others as well, but we are taking the right-handed parabola as the simple example. Now let's say ask you, what is the length of the lattice rectum of the parabola? Again, we'll take the right-handed parabola with the equation y square equal to 4ax. So guys, you remember what is lattice rectum? Lattice rectum was this line, right, which is perpendicular to the axis or axis of symmetry and passing through the focus. So we are interested in this line AB. Our lattice rectum here The lattice rectum that we are talking about is this line AB, which is perpendicular to the x-axis, and we need to find its length. So how will you do that, guys? Think about it. So remember, this is our parabola. So any point xy on the parabola, A lies on the parabola, B also lies it. Any point will be at the distance from that point to the focus and to the directrix is going to be equal. You guys agree? So I'm interested in finding this length AB. Okay. So first let's look at this part. If I ask you what is the length AF, how do I find that? We know that in a parabola, this distance AF is going to be equal to AC by the definition of parabola. Do you guys agree? AF is equal to AC. AF is equal to the AC. Distance from the focus equals the distance from the directrix. Now guys, looking at the diagram, can you tell me what is AC? AC, you can see this distance is going to be, because we know this point is, so AC is going to be the same distance as FM. You look, this is forming a rectangle and we know F is at A comma 0 and this point here is minus A comma 0. So do you guys agree that this distance FM is going to be A plus A? A plus A, right? So that's going to be the same over there, AC. So that's going to be 2A. So if AC is 2A, do you guys agree that AF is 2A? Yes, AC is equal to AF. Same way we can find BF, because BF, the distance from this point, because B is on the parabola, so distance to the focus is going to be equal to the perpendicular distance to the directrix. Now what will this distance be? This distance is again going to be the same thing as this, which is A plus A, 2A. You guys can see B, this distance, so I can say over here BF is going to be same as, let's call this point BD. BF is going to be equal to BD. I know it's not looking exactly equal in this diagram, it's a rough diagram. So BF equal to BD, and that's again going to be equal to 2A, because this is the distance here, right? So this is going to be 2A. Clear? So guys, what will this total length of the lattice rectum be? AB. AB, you guys can see, is AF plus BF. So that's going to be 2A plus 2A, which is 4A. So there you can see length of the lattice rectum is turning out to be 4A. Clear? There's another way you can prove it. So you can start with the equation of the parabola y square equal to 4AX. Okay. You're interested in finding this length AB. Okay. So what are these points? A is actually what point? A is lying at, this is the x values A, comma, you don't know its y value, so I'll say A comma y. And B lies at, this is again at A, comma, another y value, we can call it y dash. Now these lie on the parabola, that means they'll satisfy y square equal to 4AX. So if you start off with y square equal to 4AX, the x value is A, so substitute A over there. So y square equal to 4A, 4A times A, 4A square. So what will y be? Y is going to be square root of 4A square, which is nothing but 2A and plus minus. Why we are getting two values? Because plus 2A minus 2A, one value for A, one for B. Do you guys agree? So what will be the distance? If this y value becomes 2A, this becomes 2A, this becomes minus 2A, the total distance will again be 2A plus 2A, 4A. So we can say based on this, AB will be equal to 2A plus 2A, which is 4A. So guys, whichever way you look, the length of the lattice rectum, and again we looked at the right-handed parabola, the length of this line, the lattice rectum AB is going to be equal to 4A. And what is that importance of A? A is where the focus lies, right? Focus is at A comma 0. And remember we said we will take A greater than 0 for a parabola. So we have looked at the standard equation for the right-handed parabola. Remember, this is the right-handed parabola opening to the right side. So our right-handed parabola, and can you guys tell me what is the standard equation for this? Y square equal to 4x. Note it down, right? So this is the one we have discussed. Y square equal to 4ax. Now the question is, if you have the left-handed parabola, right? If you have the one on the left, So if we have the left-handed parabola, what will be the standard equation? Can you guys guess? Again, remember the focus is a comma 0. So if we talk about the focus here, so the focus for the right-handed parabola is a comma 0, and for the left-handed parabola, the focus is going to be minus a comma 0. So note, we take always a greater than 0. Okay, the value of a we take greater than 0. Here the focus is on the positive x-axis, so a comma 0. Here the focus is labeled as minus a comma 0. Focus are labeled as f. Okay. Now for this parabola, will this equation be correct? Y square equal to 4ax? No, because here all the x values are negative. Remember, these are the coordinate axis, right? This is your x-axis, your y-axis. This is your x and y-axis. So here all the x values will be negative, but y square is positive, right? Y square, square of a number is always positive. So the equation of a left-handed parabola is going to be y square equal to minus 4ax. Just one minus sign comes in. Why? Because see, all the x values are negative. So your right hand side will always be negative if you didn't put the minus sign. So that's why minus 4ax, and a we take as positive. Clear? So x value is negative, a positive, then the negative sign will cancel the negative, and left hand side will always y square be positive. Okay. So here the equation is y square equal to 4ax. For a left-handed parabola, y square equal to minus 4ax. And note, in these parabolas where you have y square term, these parabolas are about the x-axis, not about the y-axis. The axis of symmetry is about the x-axis. Now let's look at the upward and downward parabola. So now let's next talk about our upward and downward parabola. What will these equations look like? Well, they are very similar. Only thing you need to change is, instead of being y square equal to 4ax, this parabola is going to be, the equation is going to be x square equal to 4ay. X square equal to 4ay. And this one, once again remember, the focus is here, a comma 0. For this one, where is the focus? Inside the parabola, right? This curved part. Minus a comma 0, because a should always be greater than 0, remember that. And the equation of the downward parabola, this guy's equation will be x square equal to minus 4ay. So note these important things. Now how will you remember? Because it's a little confusing. The formula is very simple, but the confusion here is, should I use y square or x square? So one way to think about this is, why these y square for the right-handed or left-handed parabola? Because you can think this way, that when y square is equal to 4ax, that means y is square root of 4ax, and it will take positive and negative values. So for every x value, I'll have a positive and negative y. So that's why you can see for every x value, I will have a positive y and a negative y. Means some value, some point on the y, a positive y side, and something on the negative y. That's why y square equal to 4ax is giving you this kind of shape, where you have a positive y, a negative y. And depending on left hand, right hand side, we have a positive and negative sign. Clear? Now if you come this side, okay, the upward and downward case, if you take x square equal to 4ay, if I write that as x equal to square root of 4ay. So see, for every y value, I can have a positive x and a negative x. Take a look, guys. For every y value that you put in, you can have a positive x and a negative x. That's why it has both positive and negative x values. And you can see the axis of symmetry is along the y-axis. Clear? So one easy way you can remember, whenever we write a y square parabola, that will be about the x-axis. Whenever we talk about an x square parabola, that will be about the y-axis. Clear? So it's like the reverse. Okay? And again, remember, where is the vertex of the parabola, guys? The vertex always lies at the origin. Your vertex always will be 0, 0. So for all these parabolas, don't forget the vertex is at the origin. Clear? And then your directrix are like this. So where are your directrix? This directrix, this is at a, 0. So this directrix passes through minus a, or we can say it is x equal to minus a. This directrix passes through the positive value, so x equal to a. Here what are the directrix? Here this directrix is passing through y equal to minus a. It has a y value, and this passes through y equal to a. Clear? So draw these diagrams, visualize it, because this is a very visual chapter. It's all about coordinate geometry, understanding the parabola on the 2D plane. Equation is very simple, right? So let's revise these 4 different types of parabolas and fill up this table. So remember, we have these 4 different types of parabolas: right-handed, left-handed, upward, downward, and let's see what do their vertex, focus, etc. look like. So when we talk about the vertex, remember, vertex means this point, and vertex we said is always going to be the origin, 0, 0. So I can say the vertex of all the parabolas, all these equations that we have taken, vertex is simple, it's going to be 0, 0, the origin basically, right? Focus, where does the focus lie? Look at it guys carefully. So where is the focus? In the right-handed parabola, focus lies here. In the left-handed parabola, you know the focus lies here. Upward parabola, it lies here. And downward parabola, it lies here. Remember, focus always lies within that curved part. So can you guys tell me the coordinates of the focus? So what were we taking at? This focus will be a, 0. Remember, a value we always take as positive. It's on the x-axis, so a, 0. For this left-handed parabola, the focus is on the negative x-axis, so it will be minus a, 0. For this upward parabola, focus lies here, so it's going to be 0, a on the positive y-axis. And this one, downward parabola, it's going to be 0, minus a. Clear? Simple. So again, very visual from the diagram. You don't have to memorize. Always draw a rough diagram and figure it out. But the concept should be clear that focus lies within the curved part. Now what about the equation of the axis? Axis means this line. Don't confuse it with the directrix. Axis is the axis of symmetry, which splits the parabola into equal parts. So here, if I say what is the equation of the axis, we know this is the x-axis. Okay, x-axis, you can write x-axis, or the equation will be y equal to 0. The equation of the x-axis is y equal to 0. Same way for this left-handed parabola, which has this equation, right? So remember, y square equal to minus 4ax. Here again, the axis is this way. Okay, so the axis is going to be y equal to 0, the x-axis. For these two parabolas, the upward and downward parabolas, the axis is the y-axis. So we'll say x equal to 0, x equal to 0. So if they ask you the equation, you write it like this. Otherwise, you can simply say y-axis. Clear? And again, see in this table I've written, these are all the standard equations of the parabolas, right? Y square equal to 4ax, y square minus 4ax, x square equal to 4ay, and x square equal to minus 4ay. Next, let's look at the equation of the directrix, because directrix is also a line. We can write its equation. So this directrix, where is it? For the first parabola, it is passing through, focus is at a, 0. This is passing through minus a. This directrix passes through plus a. This directrix passes through minus a, negative. This passes through positive, right? So if you were to write the equations, how would you write it? The equation of this directrix, what would it be, guys? It is having a constant x value, right? Y value can change, its x value is constant. So we say x equal to minus a. Remember, a is always greater than 0. So don't write a, minus a. Here, again same thing, x values is constant and a is positive, so x equal to a. The next one, what will be the equation of this line? So here you can see the y value is constant, the y, right? X can change. This is going to be y equal to minus a. And the last one, the equation of the directrix, y equal to a. Clear? Next, let's fill up length of the lattice rectum. So for all these equations, what is the length of the lattice rectum? We looked at for the right-handed parabola, it was equal to 4a. 4a. What about the other guys? So all of them, remember lattice rectum. So here what will be the lattice rectum? This part. This part is going to be the lattice rectum, right? Again the length will be same. So I'll just erase that one so that you don't get confused. So here it's again going to be 4a, and it will be same for whichever type of parabola you take. Length of lattice rectum is always 4a. And the last point, what will be the equation of the lattice rectum? So now we'll have to draw it out to see where is our lattice rectum. So lattice rectum here is this one. For the right-handed parabola, for the left-handed parabola, it is this line. For this one, it is this line, and here it's this line. So what will these equations be? Simple. This is passing through a, 0, right? And this is the x value. So we can say x equal to a. X value is always fixed. So this will be the equation of this line, right? Here it is passing this way. So it's passing to minus a. X equal to minus a. Here it's passing, right, with a constant y value. So the lattice rectum will be y equal to a. And the last one will be, it's in the negative y side. So y equal to minus a. Simple. So again, don't memorize these guys. Be clear about it. Draw a rough diagram. I've just shown you the entire table just to show you all the cases, right? But I'm not asking you to memorize this. Definitely don't memorize this, right? Be clear about the visualization and you can easily do this in your rough work. Clear? So these were all the 4 parabolas and with all the standard equations. You can see it's given here. We have done the entire table for all the 4 cases. Right-handed, left-handed, upward and downward parabola. Now that you know the concept of parabola, let's practice some questions. So I want you to pick up your pen and paper here and let's try these together. Here's the first question. Find the coordinates of the focus and the vertex, the equations of the directrix and the axis. Oh my God, they've asked us a lot of things. And the length of the lattice rectum, they've not left anything, of this parabola y square equal to 8x. So guys, this is the equation of the parabola given to you in its standard form, right? The standard equation. The first thing you should do before you jump to some answers is draw a rough diagram. Always the dad trick, draw a diagram, okay? So here you can see I've just drawn the coordinate plane and now first you tell me when you look at this equation, what kind of parabola it is. You have to decide that. Is it right-handed, left-handed, upward, downward? How do we decide that? So remember we saw that if it's of the type y square, it will be about the x-axis. So it will be a right-handed or left-handed parabola, right? You guys remember that? And since there is no negative sign on the right-hand side, it's just 8x or plus 8x, it is surely going to be a right-handed parabola. So this is clear that this equation is of the type of a right-handed parabola. Clear? So guys, our parabola is going to look something like this. Again, I'm drawing it roughly here. So this is our y square equal to 8x, our parabola. And remember, where's the focus? Focus is right here at a, 0. Your directrix is on the opposite side. So this is the line passing through minus a, 0. And vertex is the origin. Okay. So what did it ask us first in the question? Find the coordinates of the focus. Focus means a, 0. But I don't know the value of a. So I will compare this equation with the standard form, right? Standard form is y square equal to 4ax. So comparing these two, you can see that 8 is equal to 4a. Can you guys see? Y square equal to 8x. So this 8 part, the constant part is 4a. So therefore we can say 4a is equal to 8 or a is 8 by 4, 2. Now I know the value of a, so I easily know the focus. So we can say focus f is 2, 0. There you go. We are done with one answer because it's at a, 0. Next it says find the coordinates of the vertex. Vertex I told you for all these standard equations, vertex is the origin, 0, 0. So we can say vertex is the origin, 0, 0. Done. The equations of the directrix. So directrix is this line. Line as an equation. It is passing through minus a. So what will its equation be? Its x value is always constant, right? So x equal to minus a. See, y value can change, but x is always constant. So directrix, we can say directrix, guys, is going to be x equal to minus a. X equal to minus a, but a's value I know. So we can say x equal to minus 2. That's the answer. Or I can directly write it here. You guys understood? X equal to minus 2. Next, we need to find the equation of the axis. Axis means the axis of symmetry, which divides the parabola, right? Like this. So this is the axis of symmetry. It's clearly the x-axis, but they've made it difficult. They're saying equation, right? So we can say the axis is basically your x-axis, and x-axis, the equation is y equal to 0, right? That's the equation. And the length of the lattice rectum. Lattice rectum, remember this part? This is your lattice rectum AB. And the length of AB, lattice rectum, was, remember the formula is very simple, 4a. 4 times 2. So So this is going to be 4 times 2. So the answer is going to be 8. And length we always write in coordinate geometry, 8 units, remember? So there you go. Those are all our answers. So again, I remind you, don't jump to conclusions. Draw a rough diagram, visualize your parabola, because all your answers will depend on what type of parabola it is. And clearly this equation is of a right-handed parabola type. Clear? So I hope all of you got these same answers here. And this concept of solving the question is clear to you. Let's try the next question. And again, I would encourage you to pause the video and try the question yourself. So what's our question? Again, we need to find the coordinates, focus, right? The axis, equation of the directrix, length of lattice rectum, blah, 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 for this parabola x square equal to 6y. So the secret is here. And of course, you're drawing your diagram. So can you guys tell me which type of parabola it is? X square equal to 6y. So you can see it is x square. That means it will lie about the y-axis. It will have a positive and negative x value, right? So it will lie about the y-axis. And since the right hand is positive, right? So it will be like a smiley parabola. Smiley because, you can remember, positive person is smiling, person who's negative is crying, right? The downward parabola. So this is clear that this is going to be an upwards parabola. All of you agree? So let's draw the rough diagram for this. So it's going to be something like this. Okay. Again, just a rough drawing. This is our parabola x square equal to 6y. Now what are we interested in finding? We have to find the coordinates of the focus. Focus, remember, is here, a comma 0. The axis, this is going to be the axis, sorry, not the x-axis, the axis of symmetry that divides it into 2 equal parts. Then you have the equation of the directrix. Directrix is here, passing through this minus a value, okay, and the length of the lattice rectum. So our lattice rectum is right here, okay. So how do we solve this, guys? Again, let's compare it with the standard equation. What is our standard equation? X square equal to 4ay. And you need to compare that with x square equal to 6y. So if you compare the equation of the parabola to the standard equation, what do you get the value of a? Simple. We can compare this and say 4a is equal to 6. So let's write that. 4a equals 6, or I can say a equals 6 by 4, which is basically 3 by 2. So once we've got this, it should be easy to get the other answers. So we can easily find the coordinate of the focus. So what will the coordinate of the focus be? In a hurry, I wrote a comma 0. It should be 0 comma a, right? The focus is not at a comma 0. It is at 0 comma a, okay? So please correct that and let's write down what will be the value of the focus. The focus point F is going to be at 0 comma a, and a is 3 by 2. There you go. We have found the coordinate of the focus. Now what is the coordinate of the axis? Axis means this axis, the axis of symmetry. So axis is going to be the y-axis. Let's write that down. Axis is the y-axis, and y-axis we know the equation is x equal to 0. So we are done with that. Then we need to find the equation of the directrix. Where is the directrix, guys? Right here. And directrix has y equal to, the equation of the directrix is going to be y equal to minus a. So note that down, guys. Y equal to minus a. And length of the lattice rectum. So lattice rectum is AB of the parabola. And remember, the length of the lattice rectum is basically 4a. So that's going to be 4 times the value of a we have found 3 by 2. So let's plug in the value and we will get 6, and remember to write units as your answer. There you go, done. So easy. Again, draw a rough diagram. Make sure you follow it. Make sure your focus point is not a comma 0, it's 0 comma a. So follow your diagram basically, right? And write the answers according to that. Guys, ready for the next question? Here it is. Once again, we have to find all the coordinates of the focus, vertex, etc. for this parabola. 5y square equal to minus 16x. So once again, compare this parabola to the standard form. So what is the standard form? Here you don't have a coefficient of y square. So remember, our standard form was y square equal to 4ax or minus 4ax. So I need to get this parabola in that form. So I can write for this parabola we can say 5y square, that means y square is minus 16 by 5, if I bring the 5 here, times x. Yes? So compare it with this parabola. And what type of parabola it is? When you have y square equal to, it's of this parabola, right? Y square equal to minus 4ax type. Y square means the parabola is going to be about the x-axis. Okay? Because it will have positive and negative y values. And minus 4ax means it's going to be a left-handed parabola, not right-handed, right? So this parabola is definitely going to be something like this. Y square equal to minus 4ax, and let's mark the focus and directrix. Let me draw a better parabola, it's not looking like a nice one. So let's draw it once again. So this way, there you go, that looks better. And let me mark the focus here. Focus is going to be somewhere here, and at minus a comma 0, it's on the negative x-axis. Your directrix will be here. This is your directrix L passing through a comma 0. So our job first is to find the value of a, which we can easily find by comparing this equation with the standard form. So I can write based on this that minus 4a is minus 16 by 5, or simply you can write 4a is 16 by 5. So the value of a is going to be 16 by 5 divided by 4. So that's basically 4 by 5. There you go. So now based on this we have found our focus. So the focus f is going to be minus a comma 0. Remember, a value should always be positive. We have got a positive a value. So focus is going to be minus 4 by 5 comma 0. Clear? So we have found the coordinate of the focus. Vertex is simple. It's always going to be 0 comma 0. So vertex here, guys, is 0 comma 0. Equation of the directrix, our directrix is right here, and this x value is constant, right? So directrix we can say is x equal to, look at it, y values are changing but x is fixed, x equal to a value is 4 by 5. There you go. And it's saying find the axis. So axis of the parabola, axis is along the x-axis. So let's write that down. Axis is basically your x-axis, which is nothing but y equal to 0. And what about the length of the lattice rectum? You have to find the length of the lattice rectum, which means this part. And length of the lattice rectum we know is 4 times a. So there you go. Let's say our lattice rectum AB is going to be 4 times a, 4a, which is 4 times 4 by 5. So I can say 16 by 5 units. Done. Please check my answers to see if the values are correct. But you guys got the idea that this is going to be a left-handed parabola, because when you look at this equation, it is a left-handed parabola. And remember to bring all the coefficients to one side, because your final standard form is y square equal to 4ax or y square equal to minus 4ax. Clear? Now let's try the next question. The next question says find the equation of the parabola with the focus at 6, 0 and directrix is x equal to minus 6. So this time we have to find the equation of the parabola. They have not given us the equation. Once again, guys, the dad trick, draw a diagram or draw a rough diagram. Okay, so here we have the coordinate axis. We have been given that focus is at 6, 0. So let me mark it here. This is my focus at 6, 0. Directrix will be on the opposite side. So it says x equal to minus 6. So somewhere here, this is my directrix, x equal to minus 6. So how will the parabola look like? Because to decide the equation, first you need to know what type of parabola. There are 4 types of parabolas. So can you guys tell me what type will this parabola be? When the focus is this way and the directrix is there, right, which is parallel to the y-axis, you can clearly see that this parabola is going to be of this type, which means your right-handed parabola. It is a right-handed parabola. And if you have a right-handed parabola, what is its standard equation? Very good. The answer is y square equal to 4ax. So our job is basically to find that a value and substitute it, right? You don't leave it just like y square equal to 4ax. You have to find out a. How do you find a? Not difficult, because you know the focus point. Remember the focus point, the focus is always a comma 0. for a right-handed parabola. And if you compare this with 6, 0, therefore we can say the value of a is equal to 6. So just substitute it here. So the equation of the parabola becomes y square equal to 4ax. I'll put a equal to 6, so 4 times 6 times x. So y square equal to 24x. Please see if you're getting the same answer. Y square equal to 24x. This is your right-handed parabola. We are done. Let's try another question here. So what does it say? Find the equation of the parabola with the vertex given to you 0, 0 and focus is minus 2, 0. So let's mark that here. The vertex is the origin 0, 0 and we had said that vertex will always be the origin and focus is minus 2, 0. That means focus is on the negative x-axis. So somewhere here, this is our focus f minus 2, 0. So guys, if the focus is there, where will the directrix lie? That's right, the directrix will be here, right? It will be at 2, 0, passing through 2, 0. So clearly, where will this parabola be? With the focus on this side, that means the parabola will open this way. So do you guys agree with me? If we draw the rough diagram, the parabola is going to look something like this. So what type of parabola is this? That's right, this is a left-handed parabola. It's lying on the left side, so it's a left-handed parabola, which means what is its standard equation? Left-handed parabola about the x-axis, it will be y square equal to minus 4ax. Remember, right hand was positive, this is negative. Now you need to find this equation. So what will you do? You will compare with the focus. Focus for this one should be at minus a, 0. And we will compare it with the point given to us minus 2, 0. So what is the value of a? A is not minus 2, a is equal to 2. Remember, a should always be positive. A should always be greater than 0. So go ahead and substitute this value. So substituting y square equal to minus 4ax, a I'm going to put as 2. So we are getting y square equal to minus 8x. Check, is that the answer you're getting? The equation of the parabola based on the question given to us, y square equal to minus 8x. Now let's try another interesting question. Again, pause the video here and try it yourself first, then look at the solution. So what do we have here? Find the equation of the parabola. So once again, no surprises. Find the equation of the parabola with vertex, again no surprises, 0, 0, passing through 5, 2 and symmetric with respect to the y-axis. Okay, so when you have symmetric with respect to the y-axis, do you guys agree the parabola is going to look something like this? Okay, so always draw a rough diagram. Make sure you draw a rough diagram and see how it looks like. Because remember, this is our x-axis, this is our y-axis. So you can see the parabola is symmetric. That means y-axis is the axis of symmetry. Okay, and this is our vertex here, 0, 0. Now it says vertex is 0, 0 and the parabola passes through 5, 2, this point. We want to find the equation of this parabola. So first of all, what type of parabola is this? This is that smiling parabola or looking upwards, right? So we can say this is a upwards parabola. Now since you have an upwards parabola, what is the standard form for it? It's symmetric about the y-axis. It has two x values, right? So it will be x square equal to 4ay. Okay, not y square equal to 4ax, x square equal to 4ay. Now you need to find the value of a. So how do you do that? See, it has been given to us that it passes through 5, 2. What does it mean it passes through 5, 2? That means this point I can substitute into the equation. It will satisfy the equation. Yes? So let's do that. Since it passes through 5, 2, so we can say passes through 5, 2, I can substitute these values. So I'll put x equal to 5. So 5 square equal to 4 times a times the y values 2. So, or we can say 25 equals 8a, or a is basically 25 divided by 8. There you go. A is 25 divided by 8. That's it. Now we just have to substitute it into our equation. So equation of the parabola is going to be x square equal to 4ay, where you just need to plug in this values. 4 times the value of a is 25 by 8 times y. So this will cancel. We'll get a 2 here. So, or I'm getting x square equal to 25 by 2y. This is the equation we are getting, right? X square equal to 25 by 2y. Please check the answer. Okay, are you guys getting this? So this is how we do it. Draw a rough diagram. We substituted the value of the point, the coordinates of the point, got the value of a, and our final answer is x square equal to 25 by 2y. Now I have an interesting homework question for you to try. So here's our homework question. Find the equation of the parabola with focus 0, -3 and directrix given to you is y equal to 3. Again, I would say draw a rough diagram. So guys, this is going to be your homework question. Make sure you draw the rough diagram, figure out the type of parabola and find out the answer. And do let me know your answers by putting it in the comments below. I look forward to reading your answers and I promise to reply to them. So go ahead and try this homework question and do put in your answers in the comments below. So remember guys, we learnt about 4 different types of parabolas. So you guys remember, this is your right-handed parabola with the equation y square equal to 4ax. That was the standard equation. This one is what? The left-handed parabola. It looks to the left side, left-handed parabola with the equation y square equal to -4ax. And remember, a is always greater than 0. And then you have your upward and downward parabolas. So this is your smiling parabola, the upwards parabola, which had the equation x square equal to 4ay, and then your downwards parabola, which had the standard equation x square equal to -4ay. So remember this very important summary, because in many questions you have to decide the type of parabola and then you solve the question based on that. So friends, I hope the concept of parabola is crystal clear to you now and you have a parabolic smile on your face. And do check out the full courses on our website manochaacademy.com and our Android app Manocha Academy. To make it easy, I'll put the links below. We have courses on physics, chemistry, biology, maths, coding and artificial intelligence. In these courses, you're going to get live classes, concept videos, quizzes, questions, mock tests and revision notes. So guys, what are you waiting for? Do check out the links given below and do share it with your friends. And if you haven't subscribed to our YouTube channel, come on, smash that subscribe button right now, because it costs you nothing, but it really motivates us to make more videos for you. And if you like this video, do hit the like button and share it with all your friends. So stay connected with Manocha Academy and just keep learning.